Hello everyone, welcome back to Math 110. We're going to take a look at lesson 1.6 today. We'll do some prep skills and then we'll go into some classwork. So our skill one that we're going to work on is how to reduce fractions. So why do we need to reduce them? Because we would like to have them in the smallest form. Okay, so I could have, this would be 400 over 600, which would be the same thing, 4,000 over 6,000. I want them in its smallest form, its least form. So how I'm going to do that is look and see if there's any numbers or factors that are common between the numerator and the denominator. So a factor is a number that divides into whichever number it is. So 2 is a factor of 4 because 2 divides into 4. 2 also is a factor of 6. 2 divides into 6. So this, the number 4 could be represented as 2 times 2. The bottom could be represented as 2 times 3. Well, I want to factor out, I want to divide out that 2 divided by 2 is just 1, so it's just a different form. And then I'm left with 2/3. Okay, so 2/3 would be the lowest term reduced. 625 is in its lowest terms because the factors of 6 are 1, 2, 3, and 6. This one is just 5, 1, 5, and 25. There's no factors in common that I can cancel out. So that's in its reduced form or it's in lowest terms. The process of writing fractions in lowest terms is called reducing fractions. It's useful to do because it's easier to work with and interpret fractions. I could see, here's a smaller thing. For example, it's a lot easier to see that 5 halves is 2 1/2 than it is to see that 180 over 72 is 2 1/2. Okay, to reduce a fraction, we're going to divide both the numerator and the denominator by any common factors. So here's that 4/6 again. That common factor is to 2. I'm going to divide 4 into 2. That's 2. And I'm going to do the very same thing to the bottom. 6 divided by 2. That's just 3. And then there's no other common factors except 1 and 2, 1 and 3. The 1, we don't worry about that one. So here's 30 and 12. Well, we've got 6 that's in common here, they're telling us. 6 divides 12 2 times, 6 divides into 35 times. So if I divide the 6 over the 6, I get the 5 halves. And really, we can do this another way, that this 30 is 5 times 6, and the 12 is 2 times the 6, and that common factor I get to cancel out. And we'll look at again those in a few minutes. Sometimes I want to take a fraction and write it in its decimal form. 3/5, you can do this on your calculator, 0.6. I might do a few of these later on for you. I'll just work them out long as a review. 3/7, sometimes I have to round these things because it starts getting either into a repeating mode where it just repeats 0.23, 0.23, 0.23, and I just want to stop it. So sometimes I will not give you the exact decimal. We'll just say approximately equal to and then round them off. Percentage is one of our key skills. We're going to be dealing with percentages all throughout this course. Decimals and percentages are basically the same thing, but we have to change the form. So when I write a decimal in percent form, I move the decimal 2 places to the right. So I'm going to take right there that point and move it over 1, 2 to make it 43.5. And then I'm going to do the opposite when I go from a percent to a decimal. So this is going to go 1, 2 to the left, and that space, I fill it with a 0. So to write a percent in fraction form, I'm going to write whatever the percent is over that 100. So I may want to reduce the 70, I want to represent 70% directly as a fraction. So that percent means per 100, so that is 70 per 100. So that's the ratio, and then I just reduce it down. And zeros are always nice because I can cancel out. Each one of these represents a times 10, 7 times 10, which is 70. Down here is 10 times 10. That common 10 I get to cancel out. So I just think about these as every time I have a 0, I can cancel out that 10 on the bottom and the top. So here's some prep skills. I'm going to switch over and see if we can do these by hand. So give me just a second. Go over into OneNote again. Opens this up to full screen. Up. Maybe for me to be on top here, they don't. Maybe I don't. Yeah, that's going to be too much. So I'm just going to write it like this. I'll have this over here, and we can work with it. Oh, there you go. That's fine. So I'm going to do a couple of these things. I want to write some fractions in lowest terms. So I'm going to start out here. I'm going to go over here, and I want to represent 12 over 16 in lowest terms. So the way I'm going to do it, I do it a couple of different ways. I can say we'll do both of these divide. Can I divide 2 into both of these? So I certainly can. So if I divide this into here, that's 6. 12 divided by 2 is 6. So that's really 2 times 6. My bottom, that's 2 times 8. So here's a common 2 and a 2. That 2 over 2, remember multiplication is commutative. So this 2 divided by 2 is 1. So this I get to cancel out to be just 1. So remember how we used to do it? We just cancel those out. And then I'll repeat. Anything in common between the two? Well, 2 again. 2 will go into my 6. I'm just going to do it like they did it this time. That goes 3, and 2 will go into 8 4 times. Or 2 times 3 is 6. 2 times 4 is 8. Those two would cancel. So this, I have nothing in common between the two. I can't divide that. There's no 3's in there. 4 can't be divided by 3, and only 1 and 3 is in there. So I would leave that like that. How about 65 divided by 80? I would start out with, let's say, how about I can get 5. I know both of these are divisible by 5. There's divisibility rules. Divisible by 2, they're even numbers. So here I'm going to go over here, and if I say, what about if I divide this by 5? What would I get? Well, there's my 5, 15. So 13, 3 times 5 is my 15 is 0. So this would be 5 times 13. 5. Let me do my eraser. It needs to be erased out. And back to here. 5 times 13. Divided by, and if I go over here, and let's right over here, divide 80 by 5. 6 would do the 30. So this is 5 times 16. Thirteen is prime. There's no multiples of anything that's going to give you 13. So that's going to be our lowest terms for that one. Okay. So there's several ways I can do this. That's kind of the easiest way that I'll look through. Look at things that I know that they're, if you ended 5 and 0, those were divisible by 5. Evens are 2. I can divide those into 2. And okay. So let me go. Let me start let me get rid of this stuff. Delete that. I'm going to do some percents to decimals now. So I want to look at, if I do 60%, if I want to represent that as a decimal. I've got my 60. I want to move from percentage to decimals. That's really divided by 100. I need to really move those over 2 places. So this is the same thing as 0.60 as far as decimals go. That's what that is. Well, 0.5%, I move my decimal. There's 1, 2, and that's where I put my new decimal. So that's going to be 0.125. That's a decimal number. Okay. Let's clean that up. Back to our pen. Now let's look at fractions to decimals. Certainly hit this on your calculator. That's the way to do it in practice, but just to review our basic math, I want to divide 5 into 3. So let's going to do some decimal division. There's my 3. That's what I want to divide in. There's my 5. So there's where the decimal place is now. Put it right here. So how many times can 5 go into 3? There's my 0. So I can always add zeros to the right. That's just, they're understood there. We just don't write them all the time. So I write a 3. And then I say, can 5 go into 30? Sure, 5 will go into 30 1 time, 2 times, 3 times, 4 times, 5 would be 25, 6 would be 30, 7 is too big. So I want to put the biggest one there. Multiply them out, 6 times 5, there's my 30. And I subtract with a 0. That's a remainder of 0. So this is 0.6. 0.6. Okay. What about 12/16? Well, let's kind of reduce this first. Instead of trying to do 12 divided into 16 and then go through that step, let's see if we can reduce it first and get it into smaller numbers. It may simplify out. Even number, so it certainly divides by 2. 2 into 12, 6. 2 into 16, 8. I can do it again. 2 into 6 is 3. 2 and 8 is 4. Lowest term, there's nothing common between the 3 and the 4. And then I'm going to go here and divide this out. So give me 1 second. Delete. Make a mistake. I want to divide 3 by 4. Make this a little straighter. Hold on. Try to do a little better job of keeping mine straight. So let me go here, here. I want to divide 4 into 3. Just like I did a while ago. 4 6s is 24, 4 7s is 28, 4 8s are 32. So we're going to go with the largest that divides in there, 28. And I'm going to subtract 28 from 3. That gives me my 2. And then I need to add a 0 here. There's going to be the 2. So what goes into 20? 5 times is the biggest. 5 times 4 is 20. Which gives us our 0. So this, our 3/4, is equal to 0.75. Okay. So again, I'll clear this up. If I go too fast for you and you're writing this down, you can just pause anytime. Now I want to go from decimal to percent. So I want to take a decimal number, 0.013. And I want to represent that as a percentage. I want to take my decimal and move it over 1, 2 places to the right. So that is going to be equal to 1.3%. Okay? How about 0.058? 0.058. Take my decimal, 1, 2 places to the right. By 5.8%. Okay. Let's go back 1 second. So I'm going to go here. And there was a couple more. I think I needed to write 75% and 15%. So let's get rid of this. Back to my pen. I'm good with black. Thank you. I want to represent 75% as a fraction in lowest terms. Okay. To do this, I just realized what a percent is. That's per 100. So I need to write that as 75 over 100 and then reduce them down to lowest terms. Here, this is this is 25, 3 times 25, 4 times 25. So I'm going to divide the top. And the bottom by 25. And then that's going to be my 3/4. Let's go down here. Let's try 15%. Well, that's 15 per 100. And 5 will go into this 3 times. 5 will go into that 20 times. And then there's our fraction in lowest terms. 3 will not divide into 20. Okay. So that was a quick review of just a few things. And this is probably going to be your hardest 0.15 to kind of get it into decimal form. You may have to work with these things. Your calculator, you may be able to use your equivalence keys, and it'll go back and forth between decimals and fractional forms the best it can. Okay. So those are guys. Let's move on through. What are the chances? Probability is our next concept that we have to work with in this class, and we'll bounce back and forth through this as we go. To kind of get an understanding of probability, probability is just how likely or unlikely things are going to happen. If I roll a dice, I've got the outcome's only going to be 1, 2, 3, 4, 5, 6. So for any one of those particular numbers, we just say that's a 1 in 6 chance. If I flip a coin, I've got 2 outcomes, head, tails. To get either one of those, that should be 1/2 or 50-50 chance on getting those. So let's make it a little more precise. The probability of an event occurring is a description of how likely it is that the event will actually happen. Probability can be described using a number ranging from 0 to 1, a percentage, if you will, between 0% and 100%, or using words like impossible, 0%, probability of 0, unlikely. If I get a 3, that's a 1 in 6 chance. Well, unlikely that I could get exactly a 3. Even chance, if I flip and I wanted to do what's the probability of getting a heads, well, it's an even, 50-50, 0.5, 50% chance. And then I've got a hand of cards, 4 8s and a king. If I pull if I wanted to get an 8, it would be 4 out of the 5 possibilities. If I pull a random card out here, 4 times out of the 5, it's going to be at 8. And then certain probability of 1, that means that it's always going to happen. It's always going to happen. There's there's no chance for it not happening. Okay. So here's some different probabilities and statements that we're going to do. Number 1, the probability of rolling a 4 with a 1 standard 6-sided die is 1/6. There's 1 side, 4 dots, 6 sides total, and I want to know the probability of just that 4. There's all the 1, 2, 3, 4, 5, 6. There's only 1 4. There's possibility of 6 outcomes, so it's just that 1 out of the 6. If I said, how about a 4 or 2? Well, there's a 4 and a 2. That's the 2 possibilities out of the 6, so it would be a 1/3. So I like to have these things into decimals probability. So I give the 1/6. That gives me my decimal. If I divide the 6 into 1 to 0.167, that's the probability number. And then I say it has a 16.7% of the time I may roll a 4. So here's the thing: on each roll you have a 16.7% chance of rolling a 4. So you expect on average to roll a 4 16.7% of the time. So this is helpful. If I did 100 times, I would expect 16.7 out of the 100 to be a 4. If I rolled a die 300 times, 1/6, that probability, or the 0.167 times 300, would be 50. I would expect, now it's not going to be that all the time. It could be more, it could be less. I could roll them sets of 300, and each set of 300s will be different, but I would be expecting 47, 48, 49, 50, 51, 52, 53, somewhere around the 50 times. So when we're thinking about these situations and computing probabilities, we use the word outcome to refer to different possible results. The 1, 2, 3, 4, 5, 6, those are the outcomes. And then we have the possibility out of the 6 distinct outcomes. Okay. When a standard coin is flipped, how many different outcomes are possible in terms of which side lands face up? Well, there's 2. There's 2 possible outcomes, heads or tails. So based on this, what is the percent chance that a single coin lands on heads? Well, I've only got one way I can get ahead, but I've got 2 possible outcomes. So it's 1/2 or 0.50 or 50% of the time I would expect a head, but that's saying 50% of the time I'm expecting a tails. So here's the 1/2, right? The probability as a fraction between 0 and 1, that's just the 1/2. Okay. Each time you flip a coin, you have a 1/2 probability of it landing heads. So we expect it on average to land heads up about 1 out of every 2 times. It could have a run of 3 times heads, 3 times tails, but after a long run, we're expecting about half of them to be heads, half of them to be tails. So here's the way that you would compute a probability. If you can think about all the ways, the number of outcomes, if you've got cards, 52 in a deck of cards, how many of those, let me see, there's 12 in a 12. We got 4 kings. So if I wanted to know the number of kings, 4 kings out of the 52 cards. What's the probability of rolling 4 with 1 die? Well, there's the probability. This is the statement. The probability of rolling a 4 is just probability of 4 is one way of getting a 4, 6 possible outcomes. So it's 1/6. If you flipped a penny 80 times, about how many times would you expect it to land heads up? 80 times, the probability is 1/2, so 50% of the time, 0.50 times 80, 40 times I would expect it to land heads up. And would I definitely get the number of heads? No. That's just, the longer I do, the more I would be expecting it to be better and better times. So if I did 20,000 flips, I would expect half of those, 10,000 of them. It would be very close to that, maybe 9,890. Here's that poker hand again. The probability diagram on page that contains a picture of a good hand of poker, 4 8s. If you were to randomly pick a card from the hand, what's the probability that it would be an 8? So out of these, I reach in there, I grab. There's 4 ways that I could come up with 8, but there's 5 cards. So here's the 4, 5, or the 8. That's 0.8 as 80%. So what about drawing a king from that hand of cards? Well, that's 1 out of the 5 cards. I've only got 1 king available, 5 cards, so that's 0.20, or 20% of the time. I've got a 20% chance. Not very likely. Okay. Each of the probabilities that we calculated so far can be found without doing any actual experiments. We know for sure that when we roll a die, if it's a fair die, there's 6 possible results and only one of them is a 4, or whichever one we're concerned with. This type of probability is known as a theoretical probability. We can list all the outcomes. We know which ones are possible and how many ways can we do. So if we had a die, I could make another statement. I could say, how many ways could we come up with an even number? And there's actually 3 6. So we could roll a 2, a 4, or a 6. So there's 3 ways to get an even number out of that die. So 3, 6, 1/2 of the ways. Now it can be difficult in determining theoretical probability. Okay, I'll list out everything. Some things I just have to do by experiment. An experiment, they call that empirical probability. I just run an experiment lots and lots of times, and then I look at how many times that number comes up. So it may not be a fair, equally likely. Something may be more. And then we can do with the empirical probability. We just do this by experiment. We just do it a long time and then see what numbers come up, and we just record those as the probability. So that's empirical probability. Okay, so that's it for this lecture. I hope you found it informative. Have a good day. We'll see you next time.